So in our yesterday session, what we discussed what is inheritance, and we discussed that inheritance is nothing but it's a mechanism, or you can say it is a process which is inheriting the properties from one class to another class, right? The class from where we are inheriting the properties, we can call that class as the base class, or we can call that class as the super class, right? Or you can also call that class as the parent class. And the class which is inheriting the properties from the parent class, we refer that class as the derived class, or you can say that is the child class or subclass. So inheritance means to take something which is already exist in the sense the things are already exist in the parent class. Instead of redefining the things again and again, what we can do, we can inherit those things from parent classes to the child classes. How we can inherit the things? Now, by establishing the parent-child relationship. Once we establish the parent-child relationship, then the child can consume all the parent non-private members. And we have discussed private member the child cannot inherit, right? So we have discussed that in our yesterday session. Today we are going to discuss the 6 fundamental rules of inheritance. Right. So today, now we are going to discuss the 6 rules of inheritance, and we will discuss each of these 6 rules with example. So let's start our today's session from rule number 1. Right. So what exactly this rule number 1 say? That in CSharp, the parent class constructors must be accessible to the child class, otherwise the inheritance would not be possible. See, whenever we are making the inheritance relationship, then there is at least 2 classes comes into the picture, right? More than 2 classes possible, but for now we are considering 2 classes. One is the parent class and one other is the child class, right? And we are making the parent-child relationship. And whenever we are making the parent-child relationship, then it is nothing but we can say it's the inheritance relationship, right? And if you want to make the parent-child relationship, the first rule that you should remember, the parent class constructor must be accessible to the child class, otherwise the inheritance would not be possible. Why the parent class constructor should be accessible to the child class? Now the reason is, right, whenever you create an instance of the child class, so before executing the child class constructor, the child class constructor will call the parent class constructor, right? If the parent class constructor is not available, then how we can call the parent class constructor, right? So the parent class constructor should be accessible to the child classes so that the child class can execute the parent class constructor. Why it is required to execute the parent class constructor? The reason is by using the child object, we can consume the parent member. Na? If we want to consume the parent member under the child object, then first of all the parent member should be created. The memory allocation for the parent member should be there. The parent member should be initialized, right? And because of this reason, we should initialize or we should call the we should call the parent class constructor to initialize the parent class member. If the constructor is not accessible, then inheritance is not possible, right? If you look at our example, what we have discussed in our previous session, right? So you can see we have created one class called A, right? And in this class, we have 2 methods, method 1 and method 2. This is our class B. And in this class, you can see we have created one method called method 3. And by using the parent class object, we can consume the members of parent as well as member of child, right? How we are consuming this 2 method, right? If you look at this method signature, it is belonging to class A only, na? How we are calling the class A method using the child class object? Because whenever we are creating an instance of the child class constructor implicitly or explicitly calling the parent class constructor, right? If you look at this example, in our example, we have not defined any constructor either in the parent class or in the child class, right? Then as a developer, if we are not providing any constructor, then who is going to provide the constructor and what type of constructor is provided? The compiler is going to provide the constructor, and the compiler provided constructor are always public parameterless, right? So in this case, if you look at this class, so this class as of now in the source code we have not defined any constructor, but when you compile this class, the compiler will provide one constructor inside this class, right? The compiler will provide one constructor inside the class A, and that constructor is going to be public as well as parameterless. Similarly, in class B, we have not defined any constructor. That means as a developer, if we are not providing any constructor explicitly, then the compiler is going to provide one constructor implicitly. That means in class B, compiler will provide one implicit constructor, and that implicit constructor, right, implicitly calling the class A constructor. That means as part of this B class constructor, you should find a constructor calling statement. This B, who is the parent class of this B class? The parent class is A. That means from B class constructor, you will see that a constructor calling statement to the A class constructor, right? Now, can anybody tell me who is the parent class of A?
Object.
Object. That means if object is the parent class, then definitely from A class constructor, we should have a constructor calling statement to its parent class. To its parent class, nothing but to the object class, right? Let us prove this, whether these constructors are there or not, whether the parent class constructor calling statement is there or not. Let us see these things. So how you can see? Now we need to check the IL code, right? So first of all, we need to check the where the exe is generated. I just copy the path, and once you copy the path, then what you need to know, what you need to do, you know. So what you need to do, you just need to open the developer command prompt, right? Once you open the developer command prompt, then what you need to type? ILDAS, intermediate language disassembler, right? Once you open the ILDSM tool, then you need to provide the path where your exe is generated, and then you need to select the exe. Open the exe. In our example, we have not defined any constructor explicitly, but if you look at this code, then you will see that this is a constructor. CTOR, this is nothing but your constructor, and this constructor is void type. Void means this constructor, you can see the parameter, the return type is void, or you can say it's not taking any parameter, right? So you can see the constructor. So this constructor doesn't take any parameter. And in A class, you can also see this is the constructor. This is a public constructor, right? So this constructor also doesn't take any parameter, right? Now if you open this code, then you will see that there should be a call. Yes, it is a call. So this constructor is calling. So this constructor calling who? This constructor calling another constructor. But this constructor of which class? Inheritance demo.a. So right now, in our example, this inheritance demo is nothing but your interface, right? And this is nothing but your class name. So what is the fully qualified? See, whenever you ask you what is the fully qualified name of a class, means the construct the namespace name followed by the class name. So this fully qualified name of A is nothing but inheritance demo.a. Fully qualified name of B is nothing but inheritance demo.b. So in this case, you can see the class B constructor, right? In this case, you can see the class B constructor implicitly calling the class A constructor. That means what? What means now before executing the constructor body of the child class, the child class constructor invoking the parent class constructor, right? So now if you look at the other, so this is the other constructor. So in this case, for class A, who is the parent class? Object is the parent class, na? From which namespace this object belongs to? System namespace. So from A class, it is invoking the parent class constructor, that is the object class constructor. So the point that you need to remember, now whenever you are creating the child class instance, the child class constructor either implicitly or explicitly calling the parent class constructor. In this case, the constructor called is implicitly. Why? Because we are using the default constructor only. We are not using any explicitly constructor in our example. So the compiler know this A class having a default constructor. The compiler know this object class having a default constructor. The compiler know this B class having a default constructor. See, whenever I'm saying default constructor means what? The default constructor means parameter less constructor. Whenever your class having parameter less constructor, then the compiler know how to call that parameter less constructor, because compiler know if I'm going to call a default constructor or a parameter less constructor, then I do not need to pass anything. I just need to call the constructor. This is the reason why the constructor, the compiler call this implicitly or explicitly default constructor automatically. See, whenever I'm saying default constructor means we have two types of a default constructor. Can anybody tell me what are the different two types of default constructors?
Two types, static and non-static.
No. I'm not talking about static and non-static. I'm saying default constructor are of two types. One is system defined default constructor and another is user defined default constructor. The currently in your application, if you are not defining any constructor explicitly, then the compiler will provide the default constructor. That default constructor means parameterless constructor. But the same thing you can also define as a developer. As a developer, if you are defining the constructor explicitly in your class without any parameter, then that constructor is said to be a user-defined default constructor. Is that clear? Because we have already discussed this thing now. In our constructor session, we have already discussed in types of constructor. What is default constructor? What are the different types of a default constructor, right? If you look at our types of constructor, right? So we have already discussed this thing. You should go with that, right? Default or parameterless constructor. System defined default constructor, user defined default constructor. What is system defined or parameterless constructor? As a programmer, if we are not defined any constructor explicitly in our program, then by default the compiler will provide one constructor at the time of compilation. That constructor is a default constructor, and the default constructor is public and parameterless, right? Then what is user defined default constructor? Now the constructor which is defined by the user without any parameter is called a user defined default constructor. You can see in this case, this is the constructor and this constructor doesn't take any parameter. So this is user defined default constructor, and if the constructor is provided by the compiler, then that is going to be your system defined default constructor. Is that clear? Guys?
Yes. Yeah.
Okay. So the point that you need to remember is, so whenever you are creating the parent class instance, right? The parent class instance means whenever you are creating the child class instance, the child class constructor, before executing its body, so first it will invoke the parent class constructor. Why it is required to execute the parent class constructor? Because we are going to consume the parent member under the child class now. So first of all, we need to initialize those parent members, right? To initialize those parent member, we need to call the parent class constructor. If we are not calling the parent class constructor, then we cannot consume the parent member under the child object. But what is the use of inheritance if we are not going to consume the parent member under the child class, right? That is no use. This is the reason why it is mandatory that the parent class constructor should be accessible and available to the child classes, right? Is that clear?
Yes.
Yes, sir. Now what I'm going to do, I want to make sure that parent class constructor is going to be executed before executing the child class constructor, right? So what I'm doing, I'm writing one console statement here, right? I'm writing one console statement here. What I'm writing constructor here, right? So in this case, you can see I'm creating an instance of a B class, right? And in this case, this is a so which kind of constructor? This one is user defined default constructor, right? Because we are providing this default constructor, and this default constructor is with parameter less, right? So that's the reason why this class B can automatically call this constructor, right? So now if you run the application, you will see that first statement to be executed is constructor A. See, constructor A is executed, then method 1, method 2, and method 3. That means before executing the child class constructor body, it will execute the parent class constructor. Now see. So what I'm going to do, I'm declaring the B class constructor, class B, right? So what I'm writing, constructor B, right? See, in this case, before executing this constructor statement should be executed. That means first it will print constructor B, and then only it is going to print constructor, sorry, first it will print constructor A, and then it is going to print constructor B, and then the order in which you are calling the methods, right? So now run the application and see the output. See, first constructor A, then constructor B, then method 1, method 2, method 3. Do we call this constructor anywhere in our application? No, we are not calling this constructor. Then how it is calling? It is implicitly called by the compiler, right? Whenever your parent class having the default constructor, then that default constructor can implicitly call by the child class constructor, right? But the question is, if the parent class having some parameter, then how we are, but then how it is going to work? That we will see. That is another rule, right? In that rule, we will see if the parent class constructor takes some parameter, then the default constructor, then the child class constructor cannot implicitly call that constructor. Why it is unable to call the constructor? How we can call the constructor? That is another rule that we will discuss. But for now, you just need to understand, whenever you are creating the object of a child class, the child class constructor implicitly calling the parent class constructor, right? So that the parent class constructor should be available and accessible to the child class. Now what I'm doing, I'm making the parent class constructor as private. As soon as I make the parent class constructor as private, then you will see one error. So what error it is saying? Now a constructor. So this A is nothing but, first A is nothing but class name. This is nothing but your constructor is inaccessible due to its protection level, right? So the parent class constructor is not available now. You cannot access the parent class constructor now, right? So this is the reason why you cannot perform the parent-child relationship. You cannot do the inheritance relationship. Inheritance relationship is only possible when the parent class constructor is available, when the parent class constructor is accessible to the child class, right? So in this case, we are making that constructor as private, and as soon as you make this constructor as private, we are getting some compilation error. If you, again, after getting this compilation error, if you try to run the application, again, your application is not going to run. It is going to give you this error, right? So in which project, which program file, at what line number, everything is going to be there. See line number 21, yes, which project is inheritance demo. You can see what program file, program.cs class file. And what is the error? The error is this constructor is inaccessible due to its protection level, right? Then you might be one ask question. If you are making this as public, right? And if you are making, but in this case, you can see this constructor is private. So how it is possible? Sir, your parent class constructor is public, and child class constructor is private. How is this possible and how it is working? See, we are consuming the parent member under the child class, right? This is the reason why parent class constructor should be accessible to the child class, but we are not consuming the child member under the parent class. Parent doesn't know who are the child, what are the properties, what are the methods defined inside the child class, right? So parent, but child know what are available inside the parent class. This is the reason why if you make this constructor as public, no issue. If you make this constructor as private, no issue, because we are consuming this member inside this same class, right? So whenever you declare something as private, we already discussed in our access specifier demo, private means private. You can use that thing only within the type. Type means within the class only. If you make this constructor as private, means this constructor can only be used within this class, right? And if you make this constructor as private, then this constructor can only be used within this class. So now I'm using that constructor within the class, so I'm able to access it, right? So the first point that you should learn and understand is parent class constructor should be accessible to the child class, otherwise inheritance is not possible. Is that clear? guys?
Yeah, but you could make it protected as well, right?
Yeah, protected. So except private. Now, if you make it protected,
No, I mean
then it's available.
in class A, it could be
Yeah,
protected and it would be accessible anyway, right?
yeah. If you make it as protected, this is accessible to the child class, right? So you can create access like this, right? But the thing is that suppose this is class. So what I'm doing, I'm creating another class. Let's say class program, right? So instead of writing this thing inside the class, so what I'm doing, I'm putting this here. So I'm making this constructor as public so that I can access from the program class, right? So in this class, you can access B because B class constructor is public. But from this class, you cannot create an instance of A class, right? You cannot create an instance of A class. Why? Because A class constructor is protected. Protected means this constructor is only available to the child classes, right? If you directly want to access this, you cannot access it from non-derived classes, right? You cannot access this constructor from non-derived classes. You can access this constructor only from the derived classes. So derived classes means here B is nothing but your derived class. From B class, you can access this. But from non-derived classes like program class, you cannot access this, right? We have already discussed this thing in our access specifier. So what are the different kind of access specifier? We have discussed 6 different types of access specifier, right? And we have discussed what is assembly, what is what is assembly, what is derived classes, what is derived classes in same assembly, what is non-derived classes, what is non-derived classes in assembly, what is derived and non-derived classes in another assembly. At what scenario, if we make the member as a private, then where we can access it. If make this member as a protected, public, protected internal, private, protected, all the 6 access specifier we have discussed in detail. The same thing is applicable everywhere. It is no matter whether you are making inheritance relationship or not. The same thing is applicable to everyone. Is that clear?
Yeah.
So one doubt here, like when we call the class B and the class B is inheriting from class A.
Yes.
So implicitly class B is going to create an object of class A here, or like, because when we make the constructor as private, why the other members are not accessible? That I'm not getting.
Sorry, if you are making the constructor as private, why others member are not accessible? That is what your question, right? And
Yes,
second, first question is if you are making object of B class, so the A of class object is also created or not? These 2 questions you have, right?
yes.
Yes. See, suppose I'm declaring some variable here, integer X, right? Integer Y, right? So what I can do, I can directly access, see, I'm just making this as public and I'm making this as a public, right? So what I can do is I can write integer result, right? And I can write X plus Y, right? I can write, give me one. So you just declare 2 member in class A, right? And in class B, you are accessing them directly. First of all, tell me when this memory when these variables are going to be created and when they are going to be initialized.
When the default constructor is called of class A.
It's not like a default constructor, right? So any constructor you created, you execute any constructor of class A, this the memory location for these 2 variable is going to be created when you execute the new keyword, and when you execute the constructor, this memory location are initialized, right?
Yes.
And in this case, we are having this constructor, and this constructor is going to initialize this member. If we are not initializing this member, can I consume this?
No.
No. And when this member are going to be initialized?
When the object is, when the instance is created.
When this constructor is called, right?
Yes.
Right. If I am not calling this constructor, is this variable are going to be initialized?
No.
If this constructor is not called, Can I use this statement?
No.
That means whenever you are calling this constructor, that means whenever this child class object is created, that means child class constructor is called, then the child class constructor calling the parent class constructor. Why it is calling? Now, because I need to initialize the parent class member. Now, until and unless I am not initializing X, Y, method 1, method 2, then how I can consume them under the child class object? Right? So because whenever I'm creating the child class instance, using child class, you can call this a method 1 and a method 2. But method 1 and method 2, when they will initialize? When your parent class constructor is execute, right? If your parent class constructor is not executing, means they are not initializing. If they are not initializing, means you cannot consume them. But using child class object, you are consuming them. What it means? Now it means the child class, whenever I'm creating the child class object, the child class internally creating the parent class object. Internally, it is initializing the parent class member. As internally, it is initializing the parent class member. So I'm able to consume them under the child class. If they are not initialized, I cannot consume them, right? And the second thing, so how we can initialize them? We can initialize them only through the constructor. There is no other options. Na? That means the parent class constructor should be accessible and available. If the constructor is not available, I cannot initialize the member. As I cannot initialize the member, then I cannot consume them. This is the reason why it is mandatory that the parent class constructor should be accessible under the child classes. Is that clear?
The one one more dot, like previously I remember actually, so constructor will initialize the variables and stuff. Constructor will also initialize the methods inside that.
Yes. See, initializing means suppose you are creating some variable, na? Right?
Okay.
If you are using, so in this, if you can directly use this variable inside here. I suppose I am creating integer res equals to, see, currently I'm not writing anything, right? Currently I'm not writing any kind of a variable declaration, but this statement is also possible, na? Right? If I'm calling this method, if these two variables are not initialized, then how I can use them inside this method?
Yes. So one small doubt here. So the variables will need memory allocation, but methods will not need memory allocation.
Methods will not need memory allocation, but method will consume this variable, na?
Okay.
You understand, na? If these variables are not getting memory, then how you can use them inside a method? Method will not get any memory allocation. Variables are only going to get memory allocation. But you are going to use those variables what you have created in your class inside your method. Then if you are going to use them, if you are going to consume them inside any method, then first of all, they should get memory allocation.
Yes. So if the methods are using those variables, then they will get in it.
See, how compiler will know whether your method are using those variable or not? In one method, you are using those variable. In another method, you are not using any variable. Na? So in this case, what is mandatory? He is saying that whether you use those variable or not, whether your class having any variable or not, to make a safe compilation, to make your program safe to run, I am making it mandatory to execute the constructor. If I am executing the constructor, then you will not get any kind of compiler error. You will not get any kind of runtime error, right? As a programmer, you might be, give me one minute. Right. So the thing is that you need to remember, you might be declare some variable or not in your class. It's possible that you can declare, you cannot declare. You might be use those variable inside your class or not. That is also possible. In one method, you might be using the variable. In another method, you might not be using those variable. right? So to make the compilation successful, to make the program execution smoothly, they make it mandatory that whether you have any variable inside your class or not, whether you use those variable inside your method or not, it is mandatory to execute the constructor. Once I execute the constructor, you will not get any kind of error, right? A constructor execution successful, whether you declare variable or not, doesn't matter. The program is going to compile. It doesn't matter whether you use the variable inside any method or not. When you run the application will consume will run smoothly. It will execute the method smoothly without any kind of errors, right? So to make this thing mandatory, they make it mandatory to execute the parent class constructor while you are creating the instance of the child class, right? So who know whether you are going to use or not? See, compiler or the people who design this framework, right? They don't know now whether you are going to declare any variable or not inside your parent class, whether you are going to use those variable or not inside the child classes, right? So they don't know. So what they make? Yes, so they make a rule. So it's a rule in programming language that if you want to make the inheritance relationship, parent class constructor should be accessible to the child class. Otherwise, inheritance relationship will not be possible. Is that clear?
Yeah. So with this, we can say that whenever the child class object is created, automatically the parent class object also is created implicitly inside, and
Yes.
all the members, whether it is variables, methods, all the members of the parent class also get initiated with that construct object creation.
Yes. Yes. Yes.
Okay.
Yes.
Okay.
Right. So this is the first rule of constructor. The second rule is that the child class can access the parent class member, but the parent class can never access any member that are purely defined inside the child class, right? So now you can see. Okay, let me make this as public, right? This is I'm making public. This is my parent class. This is my child class, right? What I'm doing, right? I'm just removing the variable declaration statements to make the thing simple, right? So now using B class object, you can access all the members, right? So this is what he is saying. The child class can access the parent class members, right? So here B is nothing but your child class. The child class can access the parent class member, that is A and B. If you move the mouse pointer over the method A and method 1 and method 2, you will see that this method belongs to class A, right? And this method 3 is belongs to class B. So using child class, you can access the parent class member. We have already discussed now. What I'm doing, I'm making this method as this instance as A. As soon as I make this method as soon as I create an object or I create an instance of class A, you can see I'm able to access method 1 and method 2, but I'm not able to access method 3. Why? Because method 3 is purely defined inside the child class. This method 3 is not defined in class A. In class A, we have only method 1 and method 2. So using A class object, I can only access method 1 and method 2. But I cannot access method 3 because method 3 is purely defined inside the child class. Is that clear?
Yeah, it's okay.
Okay. Why? See, according to law, children have rights on the parent property, right? According to law, whatever property your parent have, you can access it. But parent does not have rights on the children's property, right? But parent doesn't have. So whatever you on your property, the parent cannot claim it. Parent doesn't have rights on your property. So it is the children's responsibility to take care about their parents. So as a children, it's our responsibility to take care of our parents. But legally, parent doesn't have rights on the children's property. Exactly the same way, the parent class can never access the child members which are purely defined in the child class. You can see in this case, this is the parent class having two methods, child class having one method. So using parent object, you cannot invoke the child method. Is that clear? The second point?
Yes.
Okay. Why we are unable to access this? Because parent doesn't have rights on the children. parent don't know what are the things available inside the child class, right? Why? Because this is one class, one parent class B. So you can also create another parent class. Sorry, you can also create another child class from class A, right? So another child class from A, you can make it a C. You can give the method name a different one like 4, right? So he doesn't know who are their child, right? In this case, this class A doesn't know what are the methods available inside the child classes. But if you are creating the child class instance and if you are inheriting from A means this child class know what are the things available in class A, but the parent doesn't know what are the things available inside the child classes, right? This is the reason why when you're using the child class instance, you can access the parent class member, but using parent class instance, you can never access the child class member, right? So this is the second rule that you need to remember, right? The third rule is, let's understand what is the third rule. We can initialize a parent class variable. We can initialize a parent class variable by using the child class instance to make it a reference variable so that the reference will be consuming the memory of the child class, right? But in this case also, we cannot call any pure child class member using the reference. Okay. See, so first of all, we need to understand this concept. See, this is nothing but a, okay, right? So what I'm doing, I'm just making this, right? So I'm just making this. So I'm just commenting this one. So once I write like this, so you will see that this obj is not an instance, right? It's just a variable. You can say it is a uninitialized variable. On uninitialized variable, you cannot call any method, right? So in this case, if you look, if you try to run, you will get that use of uninitialized local variable, right? So in this case, this is just a local variable, or you can say it's just a reference variable which is not initialized. So according to the third rule, say a parent class reference variable can be initialized with child class instance, right? So what I'm doing, I'm creating a child class instance, and what I'm doing, I'm assigning this obj with this child class, right? Now this is possible, right? You can initialize a parent class reference variable using the child class instance. So this reference variable is nothing but your class A. Class A is nothing but your parent class, and this is nothing but your child class instance. And you are initializing this variable using the child class instance. Even though you are creating a reference variable of a parent class, by assigning it with the child class instance, you cannot call the child class member. You cannot call the child class member which is purely defined inside the child class. So you can see I am able to access method 1 and method 2, but while I'm trying to access the method 3, I'm getting this error, right? Why I'm getting this error? Now to understand this, we need to understand the memory architecture, right? So what is a reference? Reference in this case, this obj is just a reference. This is your B is nothing but your instance, right? So in this case, this is your instance and this is your instance and this is your reference, right? So if you look at this example, okay, P and Q, okay, so to make you understand what I'm doing, I'm making this A, P, and I'm making this as Q and making this as A, and I'm invoking using the Q and Q and Q, right? So to understand this, what I'm doing, so this is P and this is going to be your key, right? To understand this thing, you need to understand this. So reference of a class will not have any memory allocation. So in this case, this is nothing but a reference, right? This is nothing but a reference variable. So P is a reference variable, Q is a reference variable, but this reference variable pointing to an instance, right? So the reference of a class will not have any memory allocation. They will be consuming the memory of instance that is initialized to them, right? So this is nothing but instance, and what instance we are initializing, they are going to consume that memory location, right? So for better understanding, you can see. So whenever you create an instance of a queue, right, the memory, so in this statement, no memory allocation is there. In this case, an instance is created and that instance is referred or point by this reference variable key, or you can say this is an instance variable, right? So you can see whenever you create a queue, at that time, class A member and class B member both are going to get memory allocation, right? All the member are initialized. Class A member initialized, class B member initialized. And using class and this reference, it is not creating a new memory allocation. Rather, what memory allocation is created by the instances, it is pointing to that, right? See, this queue created one instance, right? So in this statement, whenever this statement is created, an instance is created. And that instance is pointed by Q. That means this memory allocation, what you can see class A member, class B member is created when you execute, when you create the instance, which is pointed by Q. So Q is pointing to this instance, right? And this reference is nothing but it's just a pointer which is assigned with Q. Q means it is going to be pointing to the same memory location, right? Both Q and P are pointing to the same memory location, right? Even though both are pointing to the same memory location, using Q, you can access both class A and class B members. Whatever member defined in class A, you can access using Q. Whatever member defined in class B, you can access using Q. But using P, you can access only class A member. Even though P is initialized with child class instance, you can only consume the class A member. You cannot consume the class B member, which are purely defined in child class. So why I'm saying the term purely defined? See, so in our coming session, we will discuss some concept called overriding, right? In overriding concept, you have one method in the parent class. You can see the same method also inside the child class. That is overriding. But in this case, and in that case, the child class method is not a pure method because the method is already defined in the parent class. But in this case, this method is not defined inside the parent class. So as this method is not defined inside the parent class, so this method is said to be a what method? Pure child class method. And using the parent class reference variable, you cannot invoke the parent class method. Now, if you look at this using Q, you can access all the members, right? But using P, you can see you can access only method 1 and method 2. But if you try to access method 3, then you will get some compile time error, right? So I'm trying to access method 3, I'll get some compile time error. What compile time error it is saying? A doesn't contain a definition for method 3 and no accessible extension method 3 accepting first argument of type. That means this method is not, this method definition is not found in class A. In class A, there is no such method called method 3. So this is the reason why. So the third point that you need to remember, even though you created a reference parent class reference variable using child class object, using that reference variable, you can only consume the parent class member. You cannot consume the child class member, which is purely defined inside the child class. Is that clear, the third point?
Sir, one question, like, then what is the need of doing the parent reference? We can do the reference of child class object so that we can have all the members to that class.
If you want to understand that things, then I need to tell you one thing. Suppose I'm declaring one method, public virtual. I'm creating method of public virtual void method 4. So I'm declaring this method 4, right? In this case, what I'm saying, I'm writing this statement method 4. So I'm creating one virtual method in parent class and I am overriding that method inside the child class, right? Override method 4, right? This is, you can say, parent method 4 and you can say this is child method 4, right? You can say this is child class method 4. Now you cannot access method 3, but you can access method 4, right? Why? Because this method 4 is not a purely defined method. This method 4 is not a purely defined method, right? And you can see, so this method 1 is inherited, method 2 is inherited, but method 4 is override, right? In this case, if you execute this statement, then what will happen? See, in this case, you can consume the method for na. See, this method 4 is going to be executed child class, right? So in this case, in previous example, you are unable to call the method 3 using parent class reference variable. But using this reference variable, you can consume the child class method, right? This is one of the use case, and you will not get clarity what I am doing, why I'm declaring this method as virtual, why I'm overriding this. Everything we are going to discuss in polymorphism concept, because inheritance is one of the fundamental principle, right? Going further, we'll use inheritance concept everywhere. And second thing, in this case, this is a reference variable. In this case, I'm assigning that reference variable to this child class instance, right? Later, right? Later, you can have multiple child classes, right? And all the child classes you can store inside this reference variable, right? Going further, once you proceed, then we'll get better clarity, right? But for now, you just need to remember, using the parent class reference variable, you can only call the parent class methods, right? Which are defined inside the parent class or which are overridden inside the child classes. But using child class, but you cannot consume the pure child class method. Suppose you want to, so what is my requirement is, so I just want to invoke, yeah, so my requirement, I want to invoke the child class methods. Child class, I want to invoke this method 1, method 2, and method 4, right? But I want to invoke this method 1 and method 2 from the parent class, but I want to invoke this method from the child classes, right? But I don't want to invoke this method. How you will do this? Using parent class, if you create instance of a parent class, then you can only consume these three. But I don't want to consume, I don't want this method to be executed. I want the child class method to be executed, the child class overridden method to be executed, right? So in this case, these two methods are going to be executed. But if you create an instance of class A, this version is going to be executed. I don't want that. I want child class. Now you have second option. You can use this child class instance, right? If you use child class instance, then you can execute these two method, right? You can execute this method, but even you can also consume this method, right? But I don't want to consume this method now. What I want these two as well as this child class method. So in this case, in that case, you need to create a reference variable of a parent class by holding the child class instance. And in this case, you can consume the method 1, method 2, and method 4. But if you try to consume the method 3, you will get some, right? So it's basically depend on what your requirement, right? Whether which methods you want to invoke, what you want to restrict, that basically decide which instance you need to create and where you need to store that instance. Whether you need to create an instance of a parent class, or whether you need to create an instance of the child class, or whether you need to store the child class instance under a parent class reference variable, right? So it's basically depend on your requirement. Understand my point?
Yes.
Okay. So then this is the third point, right? And the fourth point is that every class that is defined by us or predefined in the libraries has called a default parent class, that is object class of the system namespace. So the members equals GetHashCode, GetType, ToString of the object class are accessible anywhere. So we have already discussed this thing, right? So what we discussed, now by default every class is inherited directly or indirectly from the object class, right? If you create an instance of obj, right, then you will see that obj dot means you will get 4 methods equals GetHashCode, GetType, and ToString. These 4 methods are available to all the .NET objects. Whether you create an instance of a class A, whether you create an instance of a class B, employee class, anything, any instance or anything you created, any type you created, these 4 methods are available, right? Where these 4 methods are defined, these 4 methods are defined inside the object class, right? So you can see equals, GetType, GetHashCode, and ToString, right? So these methods are defined inside the object class. As these methods are defined inside the object class, any type you created, they are going to be available. See, A obj equals to new A, I'm creating a class obj. So you cannot give the same name. So I'm giving obj1 dot. Now equals GetHashCode, GetType, and ToString. These 4 methods you are getting from where you are getting. These methods are inherited to a class from obj class. And this method 1 and method 2, they are defined inside the class A. Right now, I'm creating instance of a B class. B obj2 equals to new B. Right now if you look at this thing obj dot see obj2 dot, then you will see equals GetHashCode, GetType, ToString. 4 methods are inherited from which class? Object class. Method 1 and method 2, method 3 and method 4. Method 1 and method 2 are inherited from
Class A.
Class A, and method 4 is from class B, and method 3 is from class B. And you can see this is from class A, and you can see this is from obj class, right? So this is the obj class. So the point that you need to remember is, so the parent class for all the classes is object, right? So in this case, who is the parent class of B?
Yeah.
Yeah.
So, and who is the parent class of A?
Object.
Object.
Indirectly, obj is going to be one of the parent class or not. It might be a grandparent, but object is also going to parent, right? How? Now, whatever available in object class that are also available in class A. Once it is available to class A, means those things are also going to be available in class B or not?
Yeah, correct.
Yes. So that means everything what you have in object class, they are going to be inherited to the child classes, right? So the point that you need to remember is, now suppose you are creating an instance of object class, then which constructor is going to be executed? Say, first of all, in this class, I'm having one constructor, class A constructor, and this is class B constructor, and I'm using this GetType method, right? So this GetType method available in object class. As this method is available in object class, so you can invoke this method using object instance. You can invoke this method using A class instance, and you can also invoke this method using B class instance. What this GetType method is going to return? The fully qualified type of this object. This object type, what is the object type? The object is a class which belongs to system namespace. So it will give system.object. And this object2 type is A. From which namespace this A is belongs to inheritance demo.a. So it will give you inheritance demo.a. And for object3, what is the type? Type is B. This B belongs to which namespace? Inheritance demo. So inheritance demo.b is going to be distinct, right? So this is the role of a GetType method. But whenever you are executing this object class, then that means this object class constructor is going to execute. Yes or no?
Yes.
Yes. Then whatever statement written inside that object class constructor, that is going to be executed. Yes or no?
Yes.
But you cannot see anything in object class because that is implemented by the framework. So they have not written any kind of a printing statement so that you can see those statements, right? But whenever I'm creating a class instance, that means a class constructor is going to be executed or not?
Yes.
But before executing the a class constructor, which constructor is going to be executed?
Object.
Object class constructor, right? And now coming to this one. So in this case, B class constructor is going to be executed.
Yes.
Right? But before executing B class constructor, which constructor is going to execute?
Constructor A and object.
Constructor A. But before executing constructor A body, it will first execute the object class constructor, right? Once object class constructor execution completed, it will come back to the place from where you call the object class constructor. From where you call the object class constructor, you call it from the B class, right? So it will execute the B class body. Once it execute the B class body, then it will come back to the place from where you call the B class constructor. From where you call the B class constructor, we call it from the A class constructor. So it will then execute the A class, right? So in this case, if you execute this application, then you will see the constructor execution statement. Like first it will execute the parent class, then it will execute the child class. In this case, when this statement is executed, right, line number 31, no printing statement, because object class constructor, they do not have write any kind of a printing statement so that you can see in the console. But after executing, this line number 32 is executed. When line number 32 is executed, it is showing obj1 type is system.object. That means this obj1 type, that is object belongs to this namespace, system namespace, and object is the class name. So this is the fully qualified name. Then I'm creating a class object, right? Whenever I'm creating a class construct, so first it will execute class a constructor or not, because object constructor is executed, but that doesn't have any kind of printing statement. So you cannot say anything related to object class constructor. But in class A, we have written one constructor execution statement. Class A constructor is called, so that what you can see. Once you execute this class A constructor, then we are showing obj2.getType. So what is the type of obj2? Inheritance demo.a, right? Then I'm creating an instance of a B class. You can see before executing B class constructor, it is executing class A constructor. Class A constructor is called, class B constructor is then called, and once it executes the B class constructor, then the object is created. And when the object is created, then it will create the it will allocate the memory for both class A member as well as class B member, right? And then you can see obj3.getType means it is going to show you the inheritance demo.p. So this is how the constructor executions are happening, right? Now to get a better clarity, what I can do, I can open the ILDSM code, right? I can open this ILDSM tool, right? I can open this code, right? So you can see from class B, we are invoking class A, right? So from the constructor, you can see it is invoking the class A constructor, inheritance demo.a class constructor, right? From class B, what we are invoking? We are invoking the object class constructor. But object class, you cannot see the ILDSM code of object class because that class is defined by the framework, right? So what is the constructor execution? Now, when we create an instance of the object class, only the object class constructor is called. But when we create an instance of a class A, two constructors are called. First, it will execute the object class constructor, and then it will execute the class A constructor. When we create an instance of a class B, then three constructors are executed. First, it will execute the object class constructor, then it will execute the class A constructor, and last, it will execute the class B constructor. Is that fine? How the constructor execution takes place in inheritance, and who is the default parent class of all the types, and why we are getting and why we are seeing those four methods whenever you create any type, why we have equals, GetHashCode, GetType, and ToString, from where these four methods are coming. You understand this point or not?
Yes.
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 Okay, the next point in CSharp inheritance is we do not have support for multiple inheritances through classes, right? You cannot create one class where that class having more than one parent classes, right? That is not possible in C# because of the ambiguity issue, right? What is this ambiguity issue? How we can resolve that ambiguity issue? Why multiple inheritance through classes is not supported? How we can achieve multiple inheritance with interfaces, right? That is a separate story altogether. I'm not going to discuss that right now. We have a separate chapter called multiple inheritances in C#. In that time, I will explain this point in detail. But for now, you just remember multiple inheritances is not supported in C# through classes, but supported through interfaces. If someone asks you multiple inheritance not supported in .NET Framework or in C#, you can say, no, multiple inheritance is supported in .NET Framework. It is not supported through classes, but supported through interfaces. You cannot say it is not supported. You can say it is not supported through classes, but supported through interfaces, right? Why it is not supported, right? What are the problems we are facing? How we can achieve multiple inheritances through interfaces, right? We will discuss this thing in detail when we discuss multiple inheritances, right? So, but for now, not now, right? And the last rule is that, see, in rule 1, we learned that whenever the child class instance is created, the child class constructor will implicitly call its parent class constructor if the parent class constructor is parameterless. But if the constructor of the parent class is parameterized, then the child class constructor cannot implicitly call its parent constructor. So to overcome this problem, it is the responsibility of the programmer to explicitly call the parent class from the child class constructor and pass value to those parameters, right? To call parent class constructor from the child class, we need to use the base keyword. So whatever definition I have written here, let me explain you through practical example. So in this class, right now, this constructor doesn't take any parameter, right? This constructor is also doesn't take any parameter. So implicitly it can call this constructor. Now what I'm doing, now I'm taking one parameter called X. So now this parent class constructor taking one parameter. Once it is taking one parameter, then the child class constructor cannot implicitly call this. Why it is not implicitly call this? Because child class constructor doesn't know what value I need to pass. Implicitly, I cannot pass any random value, right? If the constructor taking some integer value, then what integer value I will pass? Whether I need to pass 0, whether I need to pass 1 or 100 or a negative number, what value? I don't know. See, if I don't know, then I cannot call it implicitly, right? If the parent class constructor taking some parameter, then from the child class constructor, the compiler will not call it implicitly, right? If the compiler will not call it implicitly, then what is the solution? The solution is explicitly calling, right? Then as a developer, as a programmer, we need to call this constructor explicitly, right? Then how we can call this constructor explicitly? By using the base keyword. By using the base keyword, you can give some value. So once you use the base keyword and pass in some value, so this base is replaced with the parent class constructor call. So what value you are passing here, that 10 will become and sit in this variable, right? So now you can see the constructor error is gone, right? But in this case, if you want to print the X value, then you can also print the X value. So now you can see this execution is done. Okay, why I'm getting this error? Yeah, you cannot call this. Okay, right? So what I'm doing, I'm just calling some of the method, right? Right. So what I'm doing, I'm creating an instance of child class. When I'm creating an instance of child class, this constructor is called, and this constructor internally, not internally, explicitly we are calling this constructor. Now we are writing the explicitly calling statement, base keyword. Base means superclass, parent class, base class. Base class constructor invoke, and while invoking, pass this 10 value, and this 10 value is going to sit in this X variable. Now if you run the application, then you will see that X value is printed in class A constructor, right? So can anybody tell me why this output is not coming and why I'm getting this error? Because we are opening this ILDSM tool, right? As long as your ILDSM tool is open, you cannot run your application. So you need to close this one. Once you close this one, then rerun the application, right? Once you rerun the application, then you will get the output as expected, right? So you can see class A constructor is called by passing the value 10, right? So before executing this class B constructor, class A constructor body executed, and whatever value you are passing, that value is going to be stored inside this X variable, right? Now one more question, sir. If I'm creating the object 10 times, right? If I'm creating the object 10 times or 5 times, right? Every time I create the object, that object will going to pass the same value to this class constructor, right? So the same value is going to pass every time I create an instance of this class, right? I don't want that. I don't want that. What I want now, while I'm creating the instance, I need to decide what value to be stored inside this X variable, right? What it means now, dynamically I want to pass some value to the parent class constructor. Is that possible? Yes, it is possible. How? Now for that, what you need to declare? You need to declare some parameter inside your child constructor, and that child constructor will take the parameter, and what you can do, you can pass that parameter to its parent class constructor. So in this case, while creating the child class instance, you need to pass the value, right? I'm passing 10, 20, and 30. This 10 will become into this variable X, and we are passing that value also to this parent class constructor, right? So in this way, you can pass dynamic values to your parent class constructor, right? You can say 20, 20 and 30, right? So whenever you are passing this value, it is not mandatory to be used only in the parent class. Even if you want, you can also use the same value inside your child class constructor. That is also acceptable. Now you will see that the same value what you are passing is going to be consumed in both parent classes as well as inside the child classes, right? So the point that you need to remember, if your constructor taking any parameter, if the parent class constructor taking some parameter, then implicitly constructor calling is not possible. As a developer, we need to take the responsibility to pass some parameter or to call the parent class constructor by passing some parameter value. And how we can do this? Now we can do this by using the base keyword. Is that clear?